framework reference, we're also going to have a reference for mass transit abstractions. Now, if I go back to my user registered integration event consumer, I need to specify what I'm actually consuming. And this is going to be the user registered integration event. Now, this type is inside of the integration events project of the users module, which is also the public API of that module. So I'm going to add a reference to this project, and now I can implement my consume method. And what I want to do inside is the same thing I was doing inside of the ticketing API. So let's go back to our ticketing module and take a look at the ticketing API implementation. All we're doing here is sending the create customer command. So let's go ahead and do this in our integration event consumer, and let's fill in the blanks for the properties that we are missing. So first of all, we need the iSender from mediator so that we can send our command. Then we need to make this method async, and I'm also going to accept a result and throw an exception if we don't manage to handle this successfully. Now let's pass in the data that we are missing. So they're going to come from the context message property, which represents our integration event. So let's say context message email, and then context message first name, and lastly, context message last name. You could pass in a cancellation token. I don't prefer to do this. And in case this is a failure result, I'm going to throw a new evently exception for the create customer command, and I will pass in the result error if anything went wrong. And this is our implementation of the user registered integration event consumer. So now we have two components. Our domain event handler, which is taking care of the internal event that's published inside of a single module. In this case, the user registered domain event. And then this domain event is going to use the event bus to publish an integration event and notify the other modules in the system, hey, something of interesting happened, do you want to consume this message? And we do want to consume it inside of our ticketing module, where we are going to handle this message and create a new customer, effectively copying the user data into the ticketing module. At this point, I no longer need the public API of the ticketing module, so I'm going to remove this project, and I'm also going to remove the implementation from the infrastructure project. And I need to remove the call to where we are registering this with dependency injection. So now the only thing that's left is to tell mass transit to route messages to the integration event consumer that we have defined here. So let's close down anything that is not important to this cause. I'm going to leave the domain event handler with a breakpoint here because we're going to use it in our test. And this is where we need to expand our definition of the add infrastructure method. So what we need to do is to somehow tell mass transit inside of this method which consumers it should configure. So if we take a look at the add consumer method, and for example, let's take a look at the generic one, you can see that it's defined on the iRegistration configurator method. So the approach that I'm going to show you is going to be pretty straightforward. I'm just going to define a public static method on my ticketing module. It's going to accept an iRegistration configurator from mass transit. Let's call this the registration configurator. And then I can say registration configurator add consumer, and I can specify the user registered integration event consumer, which is defined in the presentation layer of this module. And now the problem I need to solve is how am I going to call this static method defined in the ticketing module inside of my infrastructure configuration type, which is in our common project. A simple implementation could be leveraging functions in C#. For example, I can pass in a function, or in this case, it's going to be an action because our method is going to be void. And this action has one argument, the iRegistration configurator. Let's call this the module configure consumers. And I'm using a name in plural because this is going to be an array. And this is how I'm going to add the consumers for all of my modules. Now, inside of my call to add mass transit, I'm going to say module configure consumers. Then I'm going to loop through all of these actions. And now I can just call this method and pass in the configure instance, which is going to allow me to register my consumers with mass transit. Now, the one thing that's remaining is to add this argument when we are calling add infrastructure. And we're going to do this here. I can use collection expressions to create a new array, and I can say ticketing module, and I can pass in the configure consumers method. So with this setup in place, let's test out our implementation of asynchronous communication between modules. I'm going to send a post request to register a new customer inside of our system. So let's hit send. and I added the breakpoint inside of the user registered domain event handler. This is going to use the event bus to publish the user registered integration event. We're also using our domain event to pass in a unique domain event ID and when this event occurred, and this is going to be useful later on when we are implementing the outbox and inbox patterns. So let's press continue, and you can see that we hit the breakpoint in the user registered integration event consumer, which is now in the ticketing module, which means that we are successfully implementing asynchronous communication between our modules. And we are now sending the create customer command, which you can see is successful. If we take a look at the output window, we can also see that these requests are executing asynchronously, because if you take a look at the logs, you can see that we are processing the get user query, then we have completed the register user command, and here is the log completing our HTTP request for registering a new user. And then asynchronously, we are triggering the create customer command, which is going to insert a new record into the database and completing the create customer command handler. So if I hit continue, I will land back in Postman and we're going to get a new user identifier. If we check the state in the database using this identifier, for example, I'm going to open up the users table first, and let's filter by this ID. Here's the user that I just registered. And if I open up the ticketing module and look for the customer with the same ID, I should expect to see the same values. And you can see that we have our data duplicated between the users and the customers table, and we achieved this using asynchronous communication with mass transit and publishing messages. In this lesson, we implemented asynchronous communication between our modules by leveraging mass transit and publishing integration events. This approach is going to allow us to significantly increase the modularity of our system by making our modules completely self-contained. Now we have a simple mechanism for duplicating the required data between our modules so that our modules don't need to reach out to the other modules in our system to get any data that they require. If they need to trigger any behavior, they can just publish an integration event, and inside of the module that's interested in this integration event, we can execute the required behavior. This also opens up the door for some pretty advanced patterns when it comes to messaging, such as leveraging at least once delivery and at least once processing using the outbox and inbox pattern, and we're going to discuss this in depth as part of a separate chapter about reliable messaging, but for now, we can slowly start to wrap up this chapter about module communication, and in the next lesson we're going to talk about eventual consistency on a high level.